All right, this video is the first page of the Chapter 6 review. Number 1 wants us to find the domain and range of each function. So we have exponential functions and logarithmic functions. That is what Chapter 6 was over. So the domain of f of x equals 2 to the x power is an exponential function. The domain is forever left, forever right. So it is all real numbers. That's how you write it in interval notation. But its range, it has an asymptote at 0, which means it approaches 0, never touches it, but then it goes up forever. Okay, that graph looks like this. Okay, and like the x-axis. So is right there. It doesn't actually touch it. That arrow just gets really close to it. Now, the function of the natural log of x is a log. And those graphs look kind of like this, where this is the y-axis that it approaches forever but never actually touches. So its domain is approaching 0 infinitely but not touching it, but then it goes to the right forever. So it is from 0 to infinity, not including 0. But its range, it is going up and down forever. All real numbers is the range. Okay, this one is log, but this time it goes right to. So log functions look like this, but this one, instead of being at the y-axis, it tells us right here that it went right 2 units. So the y-axis moved over here. Here would be x equals 2. And so our range would start at 2 and go to infinity. But remember, 2 is an asymptote. It's not going to touch it. It gets the parenthesis, not the bracket. But it is still going up and down forever. So it has the range of all real numbers. Okay. D is an exponential function. So those look like this. This one does not move up. So it is still at the y-axis. Except I drew it this way, but it had a negative out front. Oops. So it really should have been drawn this way because it's reflected over the x-axis. But its domain is still all real numbers, goes left forever, right forever. But it doesn't start at 0 and go up. It's starting from the bottom and going to 0. But it approaches 0 infinitely, does not touch it. All right, and then number 2, we want to evaluate these problems. And we're going to try to solve them without using a calculator. So for A, I want to rewrite this so I can try to figure out what x is. We're going to say this will equal x. Okay? So that means 64 to the x power will equal 4. That's how we rewrite this. And I need to know what power do I take 64 to get me the number 4. Well, it's getting smaller, so I know it's going to be a root. So it's going to be a fraction. And then I think of, okay, 4 to the third power gets me 64, so going backwards means the third root will get me from 64 to 4. And then 3 to what power gives me 1 over 27? Well, to turn it into a fraction, okay, remember, if it's a power that's a fraction, that just means a root. But this one is saying this power, I'm taking it to some power, but all of a sudden I'm getting a fraction. To move it from the numerator to denominator, it has to be negative. And then 3 to the third power gives me the 27. Okay, 9 to what power gives me 3? Well, I know the square root of 9 is 3, so that power has to be a root of 2. So that's 1 over 2. And again, if we say, okay, we'll say this equals x, so 4x equals 1 over 16. 4 to what power gives me 1 over 16? So to take 4 and make it a fraction, it has to be negative. And then 4 squared is 16. All right, number 3, we want to determine if these are growth or decay. To be growth, what is taken to the power of x has to be greater than 1. To be decay, it has to be between 0 and 1. So this is what is to the x power. That is greater than 1, so I know I have growth. Okay, this is what's to the x power. 3 halves, even though it's a fraction, it is still greater than 1. It equals 1.5. So that is growth. Okay, this has a -1 out front. Looks confusing. That's not what we're looking at. We look at what's taken to the x power. It is 3, so that is also growth. And then in D, it's 1/2 power, which is 0.5. That is between 0 and 1, so that will be decay. All right, now for number 4, it wants us to use the change of base and approximate to 3 decimal places. So because some of the calculators, most of the calculators don't let you change the base to a 3. It only has a log button. Doesn't even say what the base is. That means it's log base 10. So if we want to be able to use that button to solve, we have to do the change base formula, which is taking the log of the bigger number here, and we're going to divide it by log of the base. And then you can use that base 10 button. So just type in log 19. It puts it in parentheses. You need to end the parentheses, push division, and then divide by log base 3. And it gets you a decimal, and this says round to 3 decimal places. So I got 2.680. I'm including the 0 because I am cutting it off. It does keep going. Number 5, write each expression in the other form. So if it gives you an exponential, write it as a logarithm. If it gives you a logarithm, write it as an exponential. So if I have log base 3 of x equals 4, that means 3 to the 4th power equals x. I rewrote that. Now, this one is the natural log of x equals 5. So it is a log. I need to write it in exponential form. Remember, the natural log is the same thing as saying log base e of x equals 5. So my base is e to the 5th power equals x. Okay. Now c is written in exponential form, so I need to write it as a logarithm. So I have log base 2 of 5 equals what the power is. Okay. Now D, it has the letter E there. Okay. But E is my base, so it's log base E of 6 equals x minus 5. And we know log base E is the same thing as saying natural log of 6 equals x minus 5. All right, number 6 wants us to condense these logs. This is all log base 3. So I can condense it and have log base 3 only written one time. I'll just have everything else inside a parenthesis. So anytime you have a number out front, that becomes the power. So that's really an x squared. This 3 really makes a y squared. And this 1/2 actually needs to go on the outside of the 27z. Okay, I said 1/2, I'm sorry, 1/3. So I move that 2 over here to the x, so I start with an x squared. It has a plus sign, so that means I'm actually going to multiply the inside of the next log. And I say that's y to the 3rd power, because that 3 moved up to the power. Then it has a subtraction symbol. That means division. And inside my log, I have 27z, but all of that is taken to the 1/3 power. So the 1/3 power of 27 is 3. And then I have z to the 1/3 on the bottom. So that's as condensed as it gets. I now just have one log written. So the main thing is to remember the numbers multiplying out front need to move to the power of everything inside that log. And then addition means multiplication. Subtraction means division. All right, number 7 wants us to list 3 ordered pairs on the graph of f of x equals 3 to the x power. So that's just plugging in a point for x and getting a y. Any 3 points would work. Well, I know the easiest point to plug in is 0. Anything to the 0 power is 1. 3 to the 1st power is 3. 3 to the 2nd power would be 3 squared is 9. So there's 3 points, just easy right off the bat. Okay, so this is the first page of Chapter 6 review. There will be a video for the 2nd and 3rd page.